resultant vector. Now, this word resultant vector, from the name resultant, the last thing, the outcome of anything you are doing under vector. Anything they are asking you under vector is all about the resultant. So be very, very careful with this. Even calculation aspect of vector, anything they are asking you about vector is all about the resultant. Okay, so now let's go. What is a resultant vector? By definition, a resultant vector is that single vector. That single vector, it can be any vector here. The vector can be velocity, force, or any type of acceleration. That single vector that will have the same effect, both in magnitude and direction. Of course, vectors will have both magnitude and direction, both in magnitude and direction as original vectors acting together. Or you can say as more than one vectors acting together. That particular single vector. Okay, let's take for instance, you have a car is parked, for instance, a car is parked, and the driver needs to move the car. He needs people to push the car for him. And he calls like 4 people to help him push the car. Now, if these 4 people can move that car further from a particular place, let's say we have 4, now they're applying forces. We have 4 forces now, pushing this car with their particular magnitude. This is the car. So these 4 forces are acting at a particular point. Each of them have their own magnitude. Now, these 4 forces were able to push this car from here to another point here. Of course, there is a particular person, you can call one person that can also push this car from this point to this point. It is very possible. A single person can have the same effect that these 4 persons are having on this car, push this car from this point to this point. In this illustration now, that single person that has that same energy or force to pull this car from here to this point is called the resultant person, since we are using person here. It is called the resultant person. Why these 4 persons are referred to as the different vectors. So we have more than one vector acting at a particular point, but if we can get a single vector that can have that same effect in magnitude and direction, that single vector is called a resultant vector. So I believe it is clear now. I'll put the definition down. Okay, now by definition, I will go through the definition once again. I believe the explanation is correct, or is well explained. So we have a resultant vector is a single vector which will have the same effect in magnitude and direction as original vectors acting together. That is what you call a resultant vector. Now quickly, we are going to know when is a resultant vector maximum. When do we add to get a resultant vector? When do we subtract to get a resultant vector? This is another part of vector you should take note of. Please be very, very careful. This will help us when we enter question to solve questions. Okay, now first of all, at this level, we normally use capital R to denote resultant vector. But it depends on the type of vector actually, because if it is force, you can use capital F to denote the resultant vector. If it is velocity, you can use capital V. So it depends on the type of vector you are referring to here. But if we are just talking about vector in general, without specifying the type of vector, you use capital R. Now, since a vector has a direction, when we have a particular vector moving in this direction, we have another vector moving in the same direction but has different magnitude. Let's say that this particular vector or this particular object A is moving with a velocity of 20 meters per second towards this period, and this object B is moving the same direction but in different velocity. Let's say the magnitude of this vector is 45 meters per second. Now you are asked, what is the resultant vector? What is the resultant velocity? This is very simple. What you simply do is r, which is the resultant, or you can use capital V since you are referring to velocity, is equal to the magnitude of this plus the magnitude of this. So we have 45 plus 20. This gives us 65 meters per second. So the resultant velocity or vector of this particular action is 65 meters per second. So this 65 meters per second is that single velocity that will have the same effect as these two acting together. So that is what you call a resultant vector. So when vectors are moving in the same direction, addition occurs. We add to get our resultant vector. But the reverse is the case. Let's say we are having this object A is moving in this direction. We are maintaining the same 20 meters per second. This is object A. While object B is moving in the opposite direction. This is object B moving in the opposite direction. Now, the same 45 meters per second. In this case, these two vectors are moving in the opposite direction with different magnitudes, acting at a particular point. Now, our resultant vector R will simply be the higher magnitude, which is 45, minus the smaller magnitude, which is 20. So that gives us 25 meters per second. So when vectors are moving in opposite directions, please, when vectors are moving in opposite directions, you subtract to get your resultant vectors. But when vectors are moving in the same direction, addition occurs. So we have subtraction. We have subtraction here, while we have addition here. So I believe with this explanation, there is no problem in when do we add to get our resultant vector and when do we subtract to get our resultant vector. Now let's go over to methods of solving vectors. Anytime you are referring to methods of solving vectors, what you are talking about is methods to get the resultant vector. Anything you are doing in this particular topic is all about how to get your resultant vector. That is all. Different methods in which you can get your resultant vector. So let's move over to that now.